How's everyone doing? How was your weekend? I don't care. Okay, so I graded project 2 and I graded the midterm exam. I will have all that for you. I will post the grades today. There are a couple of students who are ill and didn't take the midterm yet, so I can't actually release the midterm so you can see it. But I will put project 2 up today. If you haven't received an email from me in like the past half hour or 45 minutes, you're doing fine. If you have received an email, then you should look, because I might be a little bit concerned about how you're doing. Okay, so take a look at that. Any questions before we get started? Yes? Oh yes, the final is absolutely cumulative. In fact, computer science is cumulative. So when you're a senior, if you end up in the operating system class, you will be expected to know like types and variables and stuff like that. So, yeah. Other questions? Okay, so there's a couple things. We're like a day behind because it's a Monday-Wednesday schedule, and we missed one Monday, and it's really annoying to me. So we're like one day behind from where we should be. So there's two things we have to get to today to talk about things that you need for the project. Would it help if the projector was on? What's going on here? Huh. Yeah. So you'll have an account. So the way you'll get your midterms back is they'll be through Gradescope. And so at some point I'll click a little button and it says show all the students the exams. And you can tell me. And you will look at your exam on Gradescope, yeah. I have mixed feelings about Gradescope. Some of it was really fast and made grading really easy for me, and some of it was way harder than grading on paper because of the way I wrote the exam. So I don't know. I'll probably try it for the final too, just to see it sort of testing out. So. And I don't expect you all to have an opinion yet because you haven't seen it, but you can tell me after the midterms how you feel about it. Okay? So that's much better, isn't it? We can see now. Okay, so one of the things we're doing in this project is we're working with functions, right? So let's talk about functions. Let's write a really simple function. A function that does something inane, like adding 2 to a number. So if we wanted to write a function that added 2 to a number, what do we have to do that? Yeah? Okay. We call it add 2. How's that? And does it need a parameter? Why? So why does it need a parameter? Exactly, because you need to tell the function what number to add to. So it's going to take an int as a parameter, okay? We can get down here, we declare int add 2, int, and we'll call this param, short for parameter, because a parameter is a thing that gets given inside here. If we have more than one, it's called a parameter list. So what do? Equals param plus 2. We added 2 to it, we're good, right? So now, if we say int x equals 5, add 2 to x, and we can just see out first to make sure that, x is what we expected, even though we have no reason to believe that it wouldn't just assign it as 5. So we can do it before and after. Okay, so here's our algorithm. In main, we declare a variable 5. We print it so we can be sure that it's 5. Don't raise your hands at me right now. Add 2 to it, and then we output again, and we're done, right? And down here, we're just adding 2 to the number, and everything is what we want, right? Yes or no? Why not? Well, we have to return? Okay. Well, no, we don't. Let's just do this. We don't have to return anything if we don't want to. So I changed int to void, and now we don't have to return anything. Perfect, right? What's going to go wrong with this? It compiled. Let's run it and see what happens. Uh-oh. It printed out 5 twice. Why did it print out 5 twice? That's probably what you're all raising your hands about, right? Why does it print out 5 twice? Because we're calling add 2, right? We put 5 in here, x is 5. 5 goes into param equals param plus 2. So obviously, any changes down here also affect what's going on up here in x. Correct? How many of you think that's correct? How many of you think it's not? How many believe I just demonstrated to you that it's not correct? All right, that was my point. The whole point of doing this is just to make sure that you understand when you pass a parameter into a function like this, any changes made inside the function are not reflected back to the main part of the program. Right? So anything we do down here won't be changed back. If we want to pass that value back, how do we do it? We have to actually explicitly say that we're going to return something, right? And we have to say return param, and we actually have to say something like x equals add 2.x. Because what's going to happen is when this function is called, x will have a 5 in it, 5 will be copied into param, param gets equal to param plus 2, which is 7. We return param, and this whole thing, add 2x, becomes equal to 7, and that gets copied into x, and when we output, we should have 7. Everybody good with that so far? Let's just make sure that's what it does. And it does, right? We can see now that we have 7 where we had 5 before. This should be kind of familiar to you, right? When I do things on video, I'm not sure how many of you have seen them. We've done it in class. I know you believe me now, right? Everybody good with that? Okay. Let me ask you a question. What if, instead of adding 2 to one number, we wanted to add 2 to two numbers? Let's say we also had int y equals 7, and we wanted to add 2 to x and y. Can we do this? Sorry, I'm just changing the variable names here to confuse things a little bit. I don't know why. So great. How's that? You all look angry or upset or distressed. We have two things. We want to get two things back, right? We want to add 2 to two numbers. So we just return two things, right? Yeah. Oh, I didn't. I forgot. Thank you for reminding me. Here. Okay, I forgot to do the function prototype, so we'll change it up here. It takes 2 ints now instead of 1. All right. Now we're good, right? We can return 2 things. You all look skeptical. I see a lot of furrowed brows. Why is that? Yeah. Why not? We're returning 2 things down here, x comma y. Why can't we return both? Let's try it and see what happens. How about that? Oh, okay. Well, I'll add a y too. I don't know. Do you think he deserves candy for that? Okay. Now I'm outputting x and y. Is that better? I'll give you candy anyway. I'm in a good mood today. Okay. Everybody good with this? So now we should be returning 2 things. All right. So let's compile this and make sure that everything's fine. Wait a minute. Uh-oh. What does that mean? Yep. You can only return one thing with functions. Some languages allow you to do this. You can return multiple things. C++ is not one of those languages. Yes? I know, I'm not really sure. I'm kind of afraid to run it now and see, because I expected the compiler to actually tell me to, like, go do something. Jesus, it worked. All right, so that's not supposed to work. So let's just pretend that didn't work. That is insane. Did it? Oh, thank goodness it only worked with one. Okay. Yeah, so the language changes over time and they change things. Okay, so it didn't work. That was good news, right? It only worked on Y. Anyway, I don't exactly know why that happened, but it didn't work. Thank you for pointing that out to me. So, everybody satisfied that it doesn't work? Yeah, I'm not sure why the compiler accepted this x comma. And no, I'm going to show you how to do this. So the whole point of doing this exercise was to show you that sometimes we need to return more than one thing at a time, and you can't actually use return for it. Like, I fully expected the compiler to yell at me and tell me that I was a bad person for even trying to do that, but, you know, it just gave me warnings and it did something unexpected, and that's not really a good thing. So, but it didn't meet our goal of returning two things, did it? How many of you all agree on that at least? How many of you agree that I look stupid when I am not able to expect what the compiler does? I think so. So anyway, okay. So we can't return two things at once. So the question is then, what can we do? Do we ever need to get more than two things back from a function? Like when? Like this, or how many of you started working on project 3? So when you have a load file function, right, aren't you sending in like 12 or 13 vectors? And don't you want them to come back different? Right? We don't call like load the subject IDs and then do return, like that. So what we're doing here, what we're doing in all this stuff, and let me just back out to the point where we're doing something sane instead of something insane, where we're only taking one int and returning one thing, okay? You know what? Never mind that. I'm just going to start a new code because I've messed everything up. What we need to do is something that's a little bit different, okay? So, if you give me 1 second, I should at least... Okay. Yes, please. Okay, so we're going to do this thing a little bit differently now. We're going to come up with a function that allows us to add two numbers at once. And you're going to see things are a little bit different. Because the way that we are going to do this is instead of having the function operate on a copy of the thing that we want it to operate on, we are going to use a little bit of magic that allows us to have it operate on the thing that we want. So for example, if we pass a value from main into the function, any changes that are made in that function will be reflected back in main. Okay? So before, we haven't seen how to do that, right? Any changes we made in the function did not reflect back in main, but I'm going to show you how to make that happen. So what we're going to do is we're actually going to do this. We're going to say void add2, and it's going to take an int and an int. And in here, we are going to do what we did before. Int x equals 5, int y equals 7, cout x, and put a space in there so it's neat, and y, and indel, and then we're going to call add2 for x and y, and then we're going to output again, and we're going to see how to make this stuff work. So we say add2, int x, int y, x plus equals 2, so I have a little less typing, y plus equals 2, and we're done. Okay? Yep. Yes, thank you. Okay. So let's just compile this and make sure it works. All right, now when we run this, what's going to happen? Are x and y going to be changed? They are not, and the reason they are not is because I haven't shown you yet the magic that make that happen. So they have not changed, see that? Okay. So right now we have what are called value parameters, because each one of these parameters gets a value passed in, but that value is copied over. So what happens here is it looks at this x inside main and says x is what? And it takes the value 5 and it sticks it in this x down here. Is this the same x as up above? No, it's not. It's an x that only lives inside this add function. So this has a value of 5. 7 gets copied into there. So they have the same values, but they are not referring to the same box in memory. Everybody see the distinction? Same numbers are in them, but they are literally different boxes. Okay? So we run it and we see nothing changes. Okay, here's the deal. We also have, these are called value parameters because they have values that are copied. We also have what are called reference parameters. A reference parameter is a parameter that does not copy the value over. Instead, it refers to the same box. And here's how you make things a reference parameter. You put an ampersand here and one there. You put one here and one here. That ampersand just says, instead of copying the value over, refer to the actual thing inside here. Everybody with me on this? So now that we have reference parameters, what should happen when we run this? It should change the value of x and y. Any changes that happen in the function to a reference parameter also happen back where things are called from. Okay? So when we run this now, we should see that things are changed. So let me compile it again. And when I run it now, whoops, when I compile it again, when I run it now, you can see these values actually changed. 7 and 9. Okay. Any questions on that? Does that make sense? Yes, sir. It's always looking back to where it was called from. So a function can call another function, can call another function, and as long as they have these ampersands, they were referring back to the same thing. So you probably don't remember this, but on like the first day or two of classes, I told you one day I would tell you about a bug that cost me like 72 hours of my life. I was writing my master's thesis. I was using C++. I had a lot of functions. I had functions call functions call functions. It was like 20 or 25 functions deep, okay? In one of my functions, in only one of my functions, I forgot the ampersand. And so what was happening is my code was running and it looked like it was getting the right answer in all the functions, and then when it got back through all these functions to where it started again, the value hadn't changed. And I did not know C++ very well, and it took me forever to figure this out. And when I added 2 ampersands, one to the function prototype and one to the function, my code started working. And here I am today. But it took me like literally 2 or 3 days to work this out because I could not figure out what was going on. I thought I had a different kind of bug, and I spent all my time looking for that other kind of bug, and I couldn't find it. And when it came down to just not having the ampersand. So, frustrating. Yes? So for this, you don't need to return anything? Exactly. There is no return. This is a void function, okay? It is a void function. So there is no return. But that doesn't mean that the values are not changed. Okay? Everybody with me on that so far? Yes? No, maybe? Yes, sir. Nope. Sure. There, different variable names now. We'll compile, we'll run, still changed. So no, they don't have to use the same variable names. Yep. I think we can do this. I don't think we can take away the space after the int and have it function and have it compile well. I think if we take away that space, it won't work. So I normally put spaces between. Well, I guess that worked too. So compiler's smarter than me. But we want to make it readable, so I normally do it like that. It's also easy to miss this when you're reading code. So it's pretty common that when you declare functions, we'll talk about this in a minute, you also declare function headers that talk about what's going to happen. Yep. All right. So we also want to do an example that has vectors, right? Just so we can kind of see what's going on. All right. Other questions? All right, so when you were looking at the code for project 3, right, I gave you some functions to work with. And what you might have noticed is that each function had a little header, right? And the header looks like this. These are what are called Java doc style comments. And what you do is this, you provide a little description. Oops. I know that's spelled wrong, I don't care. Okay, so you put a little, it's typical, like when you're working with functions, to put a little thing at the top. You can put a couple of other things. And most of these are little codes like this. Right? So if you look at that, this is pretty common. And there's different ways of doing the formatting for this. This is called JavaDoc. And what ends up happening is when you format and you put all these headers on your functions in your code, there's tools that will look at your code and will create documentation for your code based on what you have put in there. Okay? So it's super common to do stuff like this, and you should maybe do that. There's other stuff too. You can have like @author, you know. So if you have multiple people working on the code, you can add things like that. It's not required for our projects. I just want you to know that it's one of these good practices. Like this is how you sort of should look at commenting functions. All right. Everybody good so far? Questions? I'm going to do a vector example next. Any questions? All right, take a 1 minute break in place. Stretch for a second, and I will set up the next example while we're doing this. Okay, so here's what I've been doing while you've been on break. Everybody, welcome back. I'm starting to work on this function, and it's going to essentially do what we did before. We're going to have a function that says load numbers. It's going to load numbers into a vector of floats, and then all we're going to do from main is like create the vector, call it, have it things load, and go back. What I am actually using is this input.data file that we used for an earlier example. If you look at this, this file has a whole bunch of floating point numbers in it, okay? And we're just going to read those into a vector and find out how much stuff is in there. So notice that this is void. The reason it's void is that we are going to use a reference parameter in order to make sure that any changes that are made to the vector in this load function also are reflected back into main. Okay? So we can declare a vector of float, and we'll call it the vec, short for the vector. Does it need any initial size? Nope. There we go. How many things will be in here after this? How many elements are in that vector after this declaration? 0. None. Okay, if we wanted something to put in there. Here's what we're going to do. We're going to say load numbers, and we just give it the vec. And now that'll load, and when we're done, we should be able to say for int I equals 0, I less than the vec dot size, I plus plus, and we just output what's in there, cout vec sub I, and we'll put an inline there. Okay, so all this does is creates a vector, calls the function, loops over and prints out what's in there. All right. Will this compile and work as it is right now? Why are you nodding your head yes? Yeah? You do. Yeah, this will compile, but what it won't return anything. If we run it right now, it'll call the function, oops, and nothing will get output because we're not actually doing the load, okay? So we input here. Now what do? We need to declare a temporary float to hold something. We call it incoming. We say while file with numbers goes into incoming, and that should take care of reading the file, right? Float vec dot push back coming. So now we can start thinking about our programs instead of as one big algorithm as being composed of small algorithms. So our load numbers algorithm, our function is an algorithm in and of itself, right? And what we can do is we can say, okay, what does this algorithm do? It takes a floating point vector as input. Notice that this is a reference rather than a value parameter because the ampersand is there. It creates this IF stream called file with numbers that opens up the file input.data. Am I doing any error checking here? Should I be? I probably should be. We'll fix that in a minute, okay? And then we declare a temporary variable to hold things. We read the files, we read the numbers out of the file one at a time and put them in incoming. And then we shove incoming on the end of the vector. When we're done, we do not return anything, and we do not need to. Why is that? Because it is a reference parameter and not a value parameter. So things will be changed. Okay, do you think this is going to work if we try it? Now's your chance to tell me it's not and get a candy. Anyone? Why? But if I'm right, you owe me one. It worked. What you got for me? Okay, all right. All right, so that worked, right? So this is essentially how we're doing things in the project. And this is why when you saw the project and you looked at the headers, there were these ampersands in there, even if you didn't really know what they were before. Okay? Everybody good with that? Yeah? The function declaration? Yeah, let's not get into that, okay? This is the way you should do it for right now. You should declare a function prototype, and then you should put the functions after main. All right, this class we're kind of simplifying things a bit. We're actually simplifying it by not splitting our code up into multiple files. What's going to happen as you go on, you will see that you will split your code up into multiple files. And so things that like deal with one thing, like loading numbers, will be in a different file than main. And then you have to have this function prototype there. So we're trying to get you to do that now, to be in the habit, so when things get more complex later, you already have what you need. Okay? Does that make sense? Today is like apparently very Monday or something like that. You know? Is it the first day that's cold? Is that the problem? All right. So this works. But Here's the thing, right? We don't necessarily have any error checking. So let's do some error checking here, right? Because can things go wrong? Will things go wrong? Yeah, probably. So just so you know, like, I'm writing the autograder for project 3 right now. My project 3 solution is about 400 lines of code, and the autograder is up to over 2,000 lines now. So that's why the autograder isn't up. I'm sorry, there's still a little bug. Okay, so, and the reason is because I have to guess everything that you're going to do that's like crazy and try and anticipate it and catch it and give you some feedback, and that can be difficult. So, all right, so we're going to say if not file with numbers, which means something went wrong with the opening. What do we do? We could, but we already know what this is, right? We already know what the file name is, so it doesn't necessarily do us any good to tell the user to input things again. Like something's gone wrong, right? Wouldn't it be nice if we had a way to tell this function up here that something had gone wrong? How are we going to do that? I know. It's almost like you're like one of those psychics who pretends to be psychic, but just gives the customers answers that they want. Everything's going to be okay. You'll be rich. Your family loves you. So hopefully all that's true for everyone here. Yeah. Aha! We could return an error code, right? Is that what you're going to say too? All right. So notice we're not returning anything here. There is nothing that prohibits us from returning a value even if we are using reference parameters. Right? We can use reference parameters and we can return a value. So what might a good value be that we could return if we wanted to return something? To let the other thing know that there was a problem. Why 0? Okay, so that's not a bad idea. Sometimes what will happen is we can use 0, sometimes we can use negative numbers. You can use some sort of error code system to let you know what's going on. For things like loading files, here's what I like to do. I like to return an integer, and the integer that I return is actually the number of lines that I have read, right? That was able to read from the file. So let's go ahead and put a function prototype on here. A function header on here. I won't always do this in class for interest of time, but we can do it really fast, right? And I would say, loads floating point numbers from input dot data, reference parameter, right? And I would actually say something like at returns. Actually, I should give it params first. And I would say something like at returns the number of floats read. Okay? So if something goes wrong with the opening of the file, how many things did we read? So what can we return? We could return 0, but this isn't really like what happens if the file is empty? How many lines were there to be to read? 0. So is the file being empty the same thing as an error? No? Okay. So let's do this. I'm just going to use -1 as an error code, and we can say return -1. So if something goes wrong and we're not able to open this, we return -1. Otherwise, we want to return how many things we were able to read. How do we know how many things we were able to read? Yep. Absolutely. So one thing we could do, which we've seen before, is we could create a counter and put a counter in here. Is there any other way we could do it? Yep. Find the size of the vector. Both should be the same, right? Every time we push something into there, we should have a count of it. So we can either create a counter or we can just return how big the vector was. Right? Which do you want to do? Yeah, I like the size too because it's a little less code, right? All right, so now we're actually returning the size of the vector, which shows how many things. So let's make sure this still compiles and runs. It works. It still outputs numbers. What we haven't done up here is anything to like catch the return value though, right? So this load numbers is actually changing the vector, but it's also returning a code, okay? And up here we would have to do something like int return value, right, equals load numbers. And now we have captured this return value, and we can do whatever we want with it. We can look and see if it was 0. That would let us know if the file was empty. We could look and see if it was -1. That meant that something went wrong opening the file. Probably that the file was missing, or we had the wrong name or something like that. Or if it was greater than 0, we would know that there were actually lines in the vector. Okay. All right, everybody with me? I see a lot of furrowed brows today. I just don't know why. So 17-second rule is in effect. Please think of questions. If you don't understand it, please raise your hand. Yeah?
So I'm really confused regarding declaring the integers in both. So you have to declare something in both the function and the main function.
Okay. Here's the deal with functions, and we'll talk about this a little bit either if we get to it today or next class. Okay? Every function has a function only knows what's inside of it. It only knows the parameters it was passed or any variables that are declared inside of it. If they have the same name, that happens to be the same name as any other variable anywhere else in the code, doesn't matter. It really just doesn't matter. Okay? So this is called the scope of the variable. And the scope for parameters and local variables is only inside the function. Inside main, is main a function? It is. So the stuff that's declared in main only exists inside main. Okay, when you're using and, you kind of create a magic link between the two. Okay? And later in the semester, we'll actually see how this magic link works. But for right now, are you happy that I'm just calling it magic? How many are willing to accept magic exists? Great. Me too. It's a wonderful attitude. So there's some sort of magic that links the two. So even if we pass something from main to a function and they have different names, as long as that @ sign is there, they are still magically linked, regardless of what their name is, whether it's the same or different. Okay? Does that help? Yes, sir. Uh-huh. So when we say return, we're actually referring to this. Like I sort of cheated a little by saying it's a reference parameter. I shouldn't say a reference parameter really returns things. That's misleading and technically inaccurate. But is that what you're getting at? Up here? Oh, right here? Okay, got it. Is that what's confusing you? Okay, so here's the deal. You can have as many returns inside a function as you like. Doesn't matter. It's just a code, right? Computer's dumb. It's dumb very, very fast. If it happens to hit a return, it will do it without worrying about whether there's anything else there. This particular return is inside an if statement, right? So what we're saying is we try to open the file, but if something went wrong with that, we're not able to, there's no point in doing the rest of this stuff. Is there? Because the file didn't open, right? It's kind of like if I tell you to like go to the closet and bring a basket and fill the basket with cans of soup, right? And you go there and the door is locked, you're not going to be like, well, now I will pretend to put soup in the basket. Yep, when you reach that return -1, even if there's other code below, it will go right back up to where it was called from. Yeah?
You can't have two returns outside of if, so there's one in if.
So we can put as many returns in here as we like. I mean, it's one of the things that we can do in our algorithm is say, we're done processing this function, go back to where you came from. Okay? And there's no rule that there only has to be one at the bottom. You can have as many as you like. Sometimes when I'm debugging a function, I will actually put a return right in the middle, because what will happen is like I might, if I'm just debugging something, I might not want all the function to run. I might want it to do a little bit of stuff and stop. But then I end up taking it out later, okay? So return is just an instruction, just like any other. You can have it in there as many times as you like. If you execute it once, the rest of the function will not happen though, because it will go back. Does that make sense? And this one I have up here because I'm just catching an error early and then stopping processing, because if we have an error, there's no point in going on. Yeah? Yes? Okay, so let's figure out how we connect these two things here, right? So what we do is, where do we start when we're following code every single time? Int main. So we start at int main. Let's just step through this and we'll see how that works, right? Int main, vector float the vec. What does that do? Creates a vector. It's named the vec. What can it hold? How many things are in there right now? Exactly, because when we start there's 0, okay? So now we go down here and we say, oh, int retval, we're going to declare a memory box that holds an int, and it's equal to load numbers the vec. Oh, okay. What is load numbers the vec? Do we know? It's a function. How do we know it's a function? Because there are parentheses. This is great. I feel like you're getting it. So, okay. So because there are parentheses, so we know load numbers is a function, and it gets passed a parameter. What is the parameter? The vec, right? Which is the same thing we declared right up there. So let us now go down to load numbers, which is right here. Load numbers says, I take a vector of float. Oh, this is a reference parameter, and I'm calling this thing here float vec. Okay? When we called it, what did we have up here? The vec, and what do we have down here? And what does this ampersand do? It links them together. Okay? So whatever we put in here, what is the vec, is magically linked down here regardless of what the name is. Does that sort of answer your question? Does that help? Because I know this stuff's confusing, and it gets more confusing when there's more things. Yep. Uh-huh. Awesome. By the way, let me just say I'm really happy today that I'm hearing the words I'm confused or I don't understand. A lot of times you all sit there and look at me, and I'm trying to guess by looking at your faces if you don't understand, or you're concerned about something you just saw on Facebook, or you're thinking about stuff you have to do tomorrow. So it helps me to get feedback, because then I know what to talk about. So you're still confused about the ampersand. Okay, absolutely. So I should have mentioned that. So what the question was is ampersand means and, right? When you're putting two Booleans together. Is that what you're referring to? Uh-huh. Yep. Yes, that's, uh-huh. Exactly the same thing. So what I mean here with this is exactly the same thing as in the last example, okay? If it has this ampersand and it's in a function, any changes that are made to that parameter that's right after the ampersand also happen back in the main wherever it was called from. So it's exactly the same thing. Yes? Wait, let me make sure she's okay before. Are you okay with that? So it's exactly the same thing. The way you can envision it, I try when I'm teaching to give different analogies so that people, if it's a simple rule that works for you, anything that's changed down here happens up above. That works for me. If you want to think of it as like a connection, that the two are linked even though it's like an alias, right? So now you have an alias for the same thing. But whatever happens down there also happens up there. And we need that in this case because we are actually sticking a whole bunch of numbers in that vector that we want to use later. So we have to link the two. Okay. Okay, so the question is, why didn't I use the same name for the both? And the answer is that you can do that. This is a pretty simple example, right? We only have one thing that we're passing back and forth. But in your program, you might get something that's pretty complicated, right? You might have, I can only think of bad examples off the top of my head, so forgive this. So say that we're dealing with a car shop, right? And we have a function that's what color to paint this car. Okay? When you pass the car in, it's always not going to be the same car. One time it might be the Fiat, the other next time it might be the Dodge, the Buick, whatever kind of car. And so the names won't always exactly line up. Does that make sense? Exactly, exactly. So that's a really good way. So here we only have one vector of floats. We know we're going to have a float vec, but if we had like 3 different vectors that all had floats in them, it would be impossible to have the same name. So I kind of made the name a little more generic.
What if you had another int something and make it equal to the same thing? But if you had another vector, like vector float and a different name, how does it know to connect it to what vector?
Okay, so if there was a different vector passed in here instead of the vec, if we declared another one up there, and we can do that. I can show you an example in just a sec, right? Whatever name is put up here, the vec is essentially what is copied down here.
So if I had, say, another vector.
Sure. So we can do the same thing, right? Let's do this. So we could do something like, we could have another vector of float, and we'll call this another vector. How's that? The vec and another vec? Are you good with that? Right. We could do the same thing we did up here. We could say, go ahead and load this one, and we would just call it, instead of the vec, it would be another vec. That's perfectly reasonable. Because this little module, this load number module, we're reusing over and over again. And so the name that gets put in here doesn't matter. What matters is that this thing has the right type, which is a vector of float, to match down there, and it goes in that. Okay. Does that help? I know this seems a little bit weird, right? But why did I store an integer? Because we're using this integer as an indication of whether our function succeeded or not. Can we declare? Oh, no, I can't actually. Here. No nuts, right? Is that one good? Yeah, I've been trying to keep that in mind. Okay, so I shouldn't have put that int there because it was already declared. Okay, who's with me? Who's really with me? Who's sort of with me? Yeah, okay, you'll get some practice on the project. Who has a question? Yeah. Okay, so the question is, do I have any tips for how to approach this? Because it's not just one algorithm, right? It's like one thing that calls different functions that all operate on the same data, but there's different algorithms. So I tried to lay it out on the project, and I tried to describe the way that I did it. I think the first thing that you should work on is, did I say load or print? I can't remember. Did I do print first? So the first thing I would do is print, right? So what you can do is you can just write a program, int main, and you can declare some vectors in there and just manually put some code in there, right? Some values in there. And you can say subject ID square bracket 0 equals whatever, right? And you can give it some values. And I would give it 3 or 4 different rows, and then I would have them print out and make sure they're right. Because then you know your print function's working. Then what I would do is I would delete all that code that you wrote, that you had that manual stuff in there, because that's literally like scaffolding, right? Like when you build a building, you don't just build a building, you put up scaffolding and stuff to hold up the building, and when the building's standing, you take it down again. You do the same thing in your code. So if in your main function you declare vectors, you manually assign some subject IDs and weights and heights and BMI factors, all that stuff, and then print them to make sure that it's printing correctly, then you know your print function works, and you can rely on it for the next thing. The next thing I would do would be to write the load function, right? Because now when you load it, you can use the print function to test and see if it's right or not. Make sense? From there, you have some other choices. You can do stuff that sets the groups, you can do the age, you can do the statistics. I don't remember exact order I put them in there. But really, don't be afraid to write scaffolding code, right? I mean, it's annoying. I totally get it. Like, it would be like writing a paper, and like in order to write a paragraph, you had to write another paragraph, and then you deleted the first one. But it's sort of like doing drafts, and it will help you. Does that sort of help? Mm-hmm. How can you write a data file? Just use Nano. You can just type it right into Nano. That'll work if you want to write a data file. You can use the data files from the last project too. They're the same. So, and I think you have a bunch now, don't you? Didn't I give you a bunch of different cities ones? So your code, when you run it, you should be able to, for project 3, you should be able to load multiple files not just one. You should load like 3 or 4 and make sure that the statistics are all working across, even though you've loaded multiple files. Uh-huh. I fixed that yesterday. So every once in a while I realize there's a bug in my code and I update it, and sometimes I forget to make it so you can run it again. Somebody emailed me about it last night and I fixed it. Or maybe the night before. My wife was mad at me. We were watching TV and I did it on my phone. She's like, "What are you doing on your phone?" I was like, "My stupid me." So, yep. Yeah, you have a week. No. No, you have a week. You have everything you need except one thing. I want to show you one more thing, okay? And you don't even need this other thing. This you need, but you just need one more thing. So the problem is if I push this project back, you will have left time for a later project, which will actually be more complex. So now, do you remember at the beginning of the semester I said things like, have you noticed that we're on the upswing? Did I lie to you about that? No. So I've been doing this a long time, so I mean I sort of know how it works. But okay, other questions? Other questions about this? Other questions about this? All right, let's take a 1-minute break in place, and then we're going to show you one more thing that will be useful to you, okay? Okay, so one of the things we have to do in this project is we have to take menu options from people, right? They're going to enter letters, and we have to figure out what letter they entered. Now, what is one way we can do this? An if statement. So let's say we're looking to catch, I don't know, what letters do you want to catch? Y? Because I need to know to write the code. Sorry. What letter? Y, you want to use Y. Okay, so we can do something like if letter equals Y. Do we have to worry about uppercase? Yes, we do, which is annoying. So, or letter equals uppercase Y. Then we can do something, right? I need a closing parenthesis. Yep, my editor helped me here. Oh, by the way, somebody asked if I would help them figure out how to do stuff on Xcode. Anybody interested in like a little video that would show how to use Xcode instead of Nano? No? No one? No one? All right. What? It's a compiler that you can download for a Mac. So, and if you all are PC people, I can help you with that too. So, but I can definitely do a Xcode video in like 5 minutes and show you how to work in Xcode, because it's getting to the point where working in Nano is annoying, isn't it? So, but do you understand why I did it? Right? Because I don't want to crush your will to live early. Okay. So this is one way we can do it. This is kind of verbose, isn't it? What if we had to catch, yeah?
Oh, I was just gonna ask if you would be able to put the little or notation just between the Y and the Y, or do you have to do letter E?
Nope. Got to do this. Got to do it this way. Very verbose. And annoying. When things are verbose and annoying, what happens? Programmers come up with an easier, lazier way. So I'm going to show you the lazier way. The lazier way that we have is called a switch statement. Okay? And a switch statement works on like this. You have switch, you have what you're switching on, which is the thing that you're switching, comparing between. And then what you have is you have this. You can set up a number of cases. Okay. Like this. So let me just compile this and make sure that I'm not doing something crazy right here. So I could have, I forgot my notes on this. So I'm running from memory, which is always a bad thing. Okay. So I can run this, and if I say y, if I enter y, it gets a y. Okay. But notice this is a lowercase y. What if we want to add an uppercase y? We want to compare both. We can add another case, and we can just stack them right next to each other. And now it's comparing for both cases. Okay. So let me prove this to you. We will compile it. We will run it. We can enter a lowercase y. It says it got a y. We'll compile it again. We enter uppercase y. It got a y. Either one worked. Okay. Any other letters we want to be able to differentiate? X. Okay. So we can put a case X. Case uppercase X. And we can just say here we got an X. This looking good? So let's test it and make sure it works the way we think it will. So we run it, we say X. Hey, I got an X. What happens if we say we got a Y? Do you remember? Uh-oh. Yes. Exactly. So here's the deal. What happens in this switch statement is it looks for a match. And if it finds a match, it starts executing code. Okay? And it says, oh, I got a Y, so it executes that. But you know what? It keeps on going down from there. And it will do what's called falling through. And it will fall through into the next case unless we put something special in there, and the thing special we have to put in there is called a break. What that means is if you match Y, execute this, and break means stop executing this switch statement. Okay? So, almost always, actually almost always, you will want to use a break after each case. There are very few cases where you actually want to fall through. Okay, so let's actually see if that fixed it. We'll compile it. We'll run it. If we enter X, we get an X. If we run it again, enter Y, we got a Y. It did not fall through this time. Does everybody understand the difference? Everybody saw the first time it printed both Y. If we put Y, it printed both Y and X, right? Up here. That's not what we wanted. Yep. Exactly. It didn't change. Here's what happened. So let's step through. We'll start at int main, right? We declare a letter. It's going to be a character. We say cout, enter a letter. The user enters a single letter. The switch looks for that letter. Let's say we entered a lowercase y. It matches right here on this case y, because that's what it's looking for. And then it starts executing code from there. It goes down to the uppercase y, doesn't need to do anything. It goes down to the cout, and it couts something. And before, when we didn't have this break here, do you know what it did? It went down to the case, it went down to the case, it went down to the next cout. So the switch statement, this thing is the label. It will match the label, and then it will start executing from there down. But if you don't want it to go into the next cases, you have to put a break. I don't think you do. I mean, you can use them. It doesn't hurt anything. But it's just going to start executing code and dropping through. Right. My son needs braces. So, don't need braces. All right. Yes, sir. Okay. Excellent question. So, break means stop executing the switch, and so it means leave this particular block of code between these two curly brackets. Let's try it and see. Actually, I'm not sure what'll happen. Honestly, I've never tried to do this. No idea. I don't know. I don't know what's going to happen, to be honest. I think it, oh, there you go. Break statement not in the loop or switch statement. So you can't do it outside. So return means go back where you came from. Break means stop doing this particular bit of code. Yep. We can, and I haven't covered that yet because we haven't needed it, but we will talk about that. So this semester, I feel I've been like trying to rush to get you what you need for the projects that I haven't gotten into detail as many things as I would have liked. So, okay. Everybody sort of see how this case stuff works? Now, there's one more cool thing about this, is that if you want, you can use what's called a default. And the default says if it doesn't match anything else, okay, if it doesn't match anything else, you give me a heart attack. I thought for a second I'd forgot to start the recording. So, okay. So you can say default if it doesn't match anything else. Use this. So let's compile this again. Whoa, wait a minute. Oh, thank you. All right, so compiles. When we run it now, we can say enter letter Q, and it says Q is not an X or Y. Okay. Yep. Nothing would happen. You want to take it out and see? So the question is, if we didn't have a default statement and we put Q in there, so I took the default out. We'll compile it. We enter a letter Q. Nothing happens. So it didn't match. Okay. But if you have default there, it says it'll match everything. But if it doesn't match any of the above things, yep. If you had two defaults, I don't know, man. You all are really mean to the compiler. I think it should give you an error. So I think when we compile it, it's going to, yeah. Yeah, case is multiple defined. You can't define the same thing multiple times. So you can't have more than one default because it doesn't really make sense to have more than one default, right? All right. Anybody see the use of a switch statement as it applies to our project? What what is the use of the switch statement as it applies to our project? When you're getting the menu and doing stuff. And if you look back at the old assignments that I've posted solutions to, you can see I use switch statements for those. Okay? So, switch statement. Here's the weird thing. Only works on integers and characters. So you cannot use strings, you can't use floats, can't use stuff like that. So other languages you can switch on strings, you can do stuff like that, but C++ only allows you that. So pretty useful, pretty simple. The tricky thing about it is when I put this on the final exam, I will do things like take some of the breaks out to make it tricky for you to follow the flow. Okay? So I'm warning you in advance. When you're trying to trace through the switch statement, make sure that there are breaks. Because if you miss them, you will think it does stuff it doesn't do. Yep. Yeah. Yep. Let's take all the breaks out and just try it and see. So I took out all the breaks. So we'll compile it. We'll run it. We enter letter X. I got X, not an X or Y. If we do it again with Y at the top, I got Y, do we need braces? Right? All that stuff goes away. So it falls through is what it's called. Falls through between the cases. And almost always you do not want things to fall through. In fact, in the past, sometimes the compiler has warned you on purpose and said, hey, you didn't have a break. You probably needed one because it's unusual to need to fall through. Yep.
So is the default part kind of similar to like the else would be to like the way we had it structured before?
Exactly. So if we were going to make this an if-else statement, we would have a whole bunch of ifs. We would have an if letter equals Y, and then we would say else if letter equals X, and then we would say else default. So it's sort of the same thing. This is a way of combining like multiple if statements together into a more convenient thing. Only works for ints and characters though. So you can't, have the full same full range. Okay. Questions on this? It's subtle. And before the exam, I'll give you some practice questions so you can kind of practice tracing through it. Okay. All right, everybody good? One more thing I'll show you quickly before we depart for the day, if there are no more questions. 17-second rules in effect, go. Nobody looks curious, that's enough time. Okay, so. Okay, so one of the things we saw was that when we were using the break statement, we got an error message that said we had a break that was not inside a switch or a loop. And we haven't actually talked about what the break statement does. But the break statement inside a loop will mean stop doing this loop. So even if there's a loop that's going on for a long time, you can make the loop stop from inside by using a break. So let me try this. While one, cout, I want a puppy. All right, what does this program do? What does this do? Prints it over and over and over again, right? So let me allow you to experience being a parent. All right, and so sometimes you just want that to stop, right? So let's do this. Thank you. So after the millionth time, so here's our algorithm now. We start a counter. Wall 1, we output, I want a puppy. Counter plus plus. When counter gets to 1,000,000 times, you shout, go to bed, and you break the loop. Okay? So, actually I'm going to turn this down to 100,000 because it'll take a little while to run up to 1,000,000. So we'll compile this, and we'll run it. And after 100,000 times, go to bed. Okay? There was literally no stop to this loop, right? While true, it will do this loop forever. But when we execute the break says stop doing that loop. Okay? Yep. Yep. Here, you want to see here? We can have a more accurate simulation of my house. Well, if we set it equal to 10, then it'll only do it once. So I would do something like, if counter mod 10 equals 0. How about that? So this is how my house works. So my 6-year-old is dropping all these hints about wanting a puppy. He has like a poster in our room with a puppy, and he brought home this little diorama with him with a puppy and stuff like that. So this strikes us. All right, but do you all see the break actually changes that behavior, right? It means stop executing that loop. So the counter will run, it'll do this, and when it says break, it means I need to execute in the loop. And when it means end the loop, it means go to right after the last curly brace of that loop. Yep. Wherever you want. Like wherever you need it, right? The difference between a while loop and a do while loop is that it will execute at least one time. If there's a break halfway through that first execution, it will not finish the rest of the body. It'll just leave. Sure. What number do you want? Nothing would happen. 0 is false. Anything that is not 0 is true. So if we put like 9 in there, we would still get the same thing. So, okay. All right. Everybody sort of good on that? All right. There's one other thing that I will show you, and we will start it next class because I don't have a handy example. So, enjoy. I will try and get a video on how to use Xcode or something a little bit easier to do your programming. Okay, on your own laptop. Have a good Tuesday.